Section 3.2, example 9. A preliminary example of integrating these kinds of problems where k is odd. So evaluate cosine squared, sine cubed. One thing we could do is turn the cosines into sines or the sines into cosines. Actually, we can't do sines into cosines because we have an odd number here. But one thing we could do is make it to where the rest of these are like we end up with just one sine there, and the rest we could turn into cosines because it is an odd number. So let's take a look at what that's going to look like. Cosine squared x. I'm going to multiply this by sine squared x times sine x dx. So now this one here, we could turn this into in terms of cosine, so that would be sine is equal to 1 minus cosine squared x. So that's what this one here is going to be. And now we would be in terms of just cosines and sines. So cosine squared x times 1 minus cosine squared x times sine x dx. So now we could let u equal 1 minus cosine squared x. So du is going to be equal to, oh, I lied. Let u equal cosine x. So du is going to be equal to negative sine x dx. There we go. So now everywhere we see a cosine, we're going to let that equal u. So we have cosine, that's going to be u squared. And then we have times 1 minus cosine squared, 1 minus u squared. And then we have sine x dx, going to be negative du. So we could throw the negative out here. Du. And just to kind of fix this up, let's multiply that through there. So u squared minus 1 du. That's u to the power 4 minus u squared du. And now we could integrate 1 over 5 u to the power 5 minus 1 over 3 u to the power 3 plus c. We were not in terms of u's, we were in terms of x's, so let's substitute that back in. So we have 1 over 5 cosine 5x minus 1 over 3 cosine 3x and plus c. And there we go. If you have any questions, please feel free to ask. Otherwise, bye.